So these are some of the topics that you must go through before you go to sit for a paper 1 mathematics. So make sure you know at least how to calculate the mathematical problems that involve linear motion. Linear motion is where you have two passes coming to meet, two passes going on the opposite sides. You know how to use the speed, the relative speed. So you must know that. The volume of a cone, the volume of a pyramid, the volume of a frustrum, the volume of a sphere, you must know how to calculate that before you go to a paper 1 mathematics paper. Surface area of a trapezium, a cone, surface area of a prism, surface area of a frustrum, the surface area of the two intersecting circles. Those are some of the mathematical problems you must know how to solve before you go, if you want to score 50 marks in section B. Another question is statistics. Statistics 1 only. Statistics 1. You should know how to calculate the mode, the median, the mean. After that, you should know how to draw an histogram, the bar graphs, the frequency polygon. So those are the things you must know before you go to paper 1 mathematics. Another one is pairing and survey form 1 work. You should know how to draw those survey questions. The next one is kinematics, which is the application of differentiation and integration in form 4. That one you should know also very well. So you should ensure you have gone through that. There are so many other topics around I have not mentioned, but if you do this, be sure that out of this, the one I mentioned here, 1, 2, 3, 4, 5, 6, at least 4 will be there. Let us look at this question. The acceleration of a particle from rest is given by A. A stands for acceleration, equal to 10 minus 3t. T is for time. Find the A, velocity after 2 seconds, B, acceleration after 2 seconds, and then finally C, the distance from the starting point to where it is momentarily at rest. So we want to start here. How do we calculate velocity? Because we have acceleration. So once we are at acceleration, for us to calculate velocity, we integrate acceleration. So let us integrate acceleration and we will get velocity. So to get velocity equal to, this is the sign for integration. We are integrating 10 minus 3t. So let us integrate that, and then we put bracket dt. When we integrate, we put like that. So you should always remember that at rest t is equal to 0 and the velocity is equal to 0. When a particle is at rest, nothing is happening. So let us integrate this. I hope you know how to integrate. So because it dt, so we are going to here we are going to have 10 t. So velocity is equal to 10t. We add t here minus 3t plus what it is. This t is raised to power 1, so we add 1, that is 2, and then we divide by the power 2, right? After that one, but we are asked you to find the velocity after 2 seconds, that is time. So when t, or after 2 seconds, what will be the velocity? So where we have t, we substitute with 2. So velocity is equal to 10 times 2 minus 3 into 2 raised to power 2 divided by 2. So velocity here equal to, this is 20 minus 412 divided by this, that is 6. And that velocity is equal to 14 meters per second. Acceleration Find acceleration after 2 seconds. So we have already acceleration. So we know that acceleration is equal to 10 minus 3t. So after 2 seconds, we just substitute, because this is time. 2 seconds is t. So we substitute t in the acceleration, and we get the acceleration when time is 2 seconds. So that is 10 minus 3 into 2, and that is 10 minus 6, which will give us 4 meters per second square, because acceleration, this is the SI unit of acceleration, meter square. Find the distance from the starting point to where it is momentarily at rest. So we are calculating a distance. But remember, distance equal to when you integrate velocity. For you to get the distance, you integrate velocity. So distance is given by s. We usually use s standing for distance. So distance is equal to integration of velocity. But we have velocity. Do we have velocity? Yes, we have velocity. Our velocity is tt minus this. So we are integrating 10t minus 3t square over 2 d. Therefore, s equal to, now let us integrate this one. This is 10t. This t is raised to power 1. So we add 1 divided by 2. See, this one is going to give us 10 t 1 plus 1, which is square, divided by the square 2. Minus, this is 3. This is 2. So 2 plus 1 is 3. Divided by 2. 2 times 3 is going to give us 6. Right? So this one is, this we want here. So we will have 5t square minus this one's here twice, t3 divided by 2, and this is distance. But we know that the particle is momentarily at rest when velocity equal to 0. If it is at rest, velocity is equal to 0. And what else is at 0? So our velocity, we had velocity which is 10t minus 3t squared divided by 2. This one we equate to 0 because at rest, velocity is 0. We want time here. So this one will give us 10t equal to, this one equal to this side, 3t squared divided by 2. So we want to eliminate this 2 from here. We multiply times 2 times 2. So we will have 20t equal to 3t squared. So we can divide by both sides by 3. So divided by t, we will have 20 equal to 3t. So divide by 3, divide by 3. So t equal to 20 divided by 3. Now we have time when the particle is momentarily at rest. Time will be 20 over this. Now we take this time and substitute to our distance. So s equal to 5. Instead of t square, now we are going to put 20 over 3 raised to power 2 minus. Instead of t cube, we are going to have 20 over 3 raised to power 3 divided by 2. This one will give us 2 over 3 minus 148, 4 over 27. And this one will give us 74. 4 over 27, and that is in meters. And that is the distance from the starting point to where the particle is momentarily at rest. Another question is here. The velocity in meters per second of a particle moving in a straight line after t seconds is given by v equal to 4 plus 8t minus 2 square. Calculate the acceleration of the particle after 3 seconds. Now we have speed, velocity, that is velocity here, we call it velocity. We want acceleration. How do you get acceleration? So from velocity to acceleration you differentiate. So now we have v equal to 4 plus 8t minus t square. So to get acceleration you differentiate. So acceleration equal to dv equal to dv over dt, which is, now we differentiate, this one is 0, this one will be 8, this one will be minus 2t, and that is velocity. So because I hope you know how to differentiate a function. So I'm thinking that you know how to differentiate as a function. So but we are told to find acceleration of the particle after 3 seconds. So where we have t, we are going to substitute with 3 because 3 is the time. So that means acceleration equal to 8 minus 2 into 3, which is equal to 8 minus 6, which is the same as 2 meters per second square, and that is acceleration. B, the distance covered by the particle between time equal to 2 seconds and time equals 6. So these are the limits. So we want the distance. How do you get the distance? Distance is equal to s. So we integrate velocity for us to get, you should know those things, that if I want the distance and I have velocity, what I will do, I will integrate. If I have velocity, I want acceleration, I will differentiate. So those are the things you need to understand. So distance is we use s to stand for distance equal to integration of velocity, and our velocity is 4 plus 8t minus t square. We put a bracket and then dt. So let us integrate this. We remove the integration function, but we have the limit. Remember the limit, our limit is time equal to 2 and up to 6. So you should remember that. So we are integrating this function under the limit 2 to 6. So let us integrate this one. So we will have 4t plus 8 t square divided by 2 minus t cube divided by 3. Our limit, the upper limit is 6, the lower limit is 2. So we are integrating this one there. So this one is the same as 4t plus this one's here, that is 4t square minus t cube divided by 3. I've simplified 6, 2. So let us now, this one, it is time. Therefore, where we have t, we are going to substitute by 6 and then later by 2. So we are going to have 4 into 6 plus 4 into 6 square minus 6 cube divided by 3, everything minus, when the limit is 2, that is 4 into 2 plus 4 into 2 square minus 2 to power 3 divided by 3, and everything here will give us 96 minus 21.25. This one will give us 74.1/3 meters, and that is the distance. Determine or calculate the time when the particle is momentarily at rest. The time when the particle is momentarily at rest. Always remember that when a particle is momentarily at rest, velocity equal to 0. Very important. So our V equal to 4 plus 8t minus t square. But now this velocity 4 plus 8t minus t square is equal to 0. So we want to get time when velocity is 0. So I will have t equal to negative 0.472 or t equal to 8.472. That is the time when you find this value. You will find the value of t to be this or this. Now we have time to be negative and another time which is positive. Time cannot be negative, therefore you ignore the value with negative. That tells you that the required time equal to 8.472 seconds. So the time when the particle is momentarily at rest is 8.472 seconds. Ignore the negative because time cannot be negative. Calculate the distance covered at the end of 3 seconds. At the end of 3 seconds. This means you find the distance when time equal to 0 and time equal to 3, because covered at the end. So we know distance s equal to integration of velocity dt. We integrate velocity. Now this one equal to, our velocity is 4 plus 8 t minus t square dt, but our limit is from 0 to 3. So let us integrate. This one is going to give us 4t plus 4t square minus 3 minus t 3 over 3, but our limit is 3 to 0. So when we use that one, we get, so substitute t with 3, so that is 4 into 3 plus 4 into 3 square minus 3 cube divided by 3. This one will give us 39 minus 0, and the answer is 39 meters. So the distance covered at the end of 3 seconds. You remember we are asking at the end, so it must have started at somewhere at the 0 so that it can end at 3. So that is the only trick in this sum. Part E of the question is that calculate the distance covered during the 4th second and of its motion. Calculate the distance covered during the 4th second of its motion. The 4th second. No, now during. Would you start from 0 to 4? No. During the 4th second, it means between the 3rd and the 4th second. That is the only trick you need to know. The distance covered during the 4th second means the time between the 3rd second and the 4th second. So you integrate velocity using the limits of 3 and 4 seconds. That's as simple as that. So find the distance. Now we are finding, we know that distance is equal to integration of v dt. So we know that the integration, that is 4 plus 8t minus t square dt. This one is going to be 4t plus 4t square minus t cube over 3, and our limit is going to be 4, 3. So this one is going to give us, so when you substitute everything here, you get 58, 2 over 3 minus 39, and that one is going to give you 19.2 over 3, or 19.2 over 3, or 19.67 meters. The curve y equal to x squared minus 2x plus 2 and the line x plus y equal to 8 intersect are shown below. So you can look at the graph. This is where the straight line which has an equation of x plus y equal to 8, and the curve which has an equation of y is equal to x squared minus 2x plus 2, and that is where they are intersecting. This is point A and this is point B, so they are intersecting at this point. So the first question we asked is that find the coordinates of the points A and B. So how do you get the points of A and B? It is very simple. We have the equation of the straight line and we have the equation of the curve. So what you do, just equate the two equations, equate them. So when you equate them, you are going to get the value of x. Once you get the value of x, you are done. So let us do that. X squared minus 2x plus 2, you just equate with this line here. So why are we equating them? Before we equate, you must ensure that every equation is in the form of y equal to. So we want to make this equation into y into, so this way if I make this equation into y, so I will start y equal to 8 minus x. You must ensure that. So we will not equate if we have not written the equation in the form of y equal to. So that is equal to 8 minus x. So like terms together, x squared minus x minus 6 equal to 0. We are liking terms together. So we want to look for the two factors which will give us the roots. So that's x squared minus 3x plus 2x minus 6 is equal to 0. This means that x squared minus 3x plus, so what have I done? Let me not jump so what I'm doing here is that here we have looked for the factors. I hope I'm going faster because I know you know how to, I think that you know how to get the factors. The factors that are going to give us the sum and the product. So this is x into x minus 3, and then 2 plus 2 into, the common factor here is 2x, that is 2 into x minus 3 equal to 0. So we are going to have x plus 2, x minus 3, the answer is 0. So this means x equal to negative 2 or x is equal to 3. That's what it means. So now we have the value of x, but we know that y equal to 8 minus x. Now we can get the value of x at this point. We also know that y equal to x squared minus 2x plus 2. So this value you will check by yourself. When you substitute the value of y here and the value of y must be the same at a given point. It must be the same. So substitute the values, the x values in x plus y is equal to 8 to get y's respectively. So at x equal to 3, when I'm using this, it means that y is going to be 5. You substitute. So it means the coordinate at b, the coordinate at b equal to x is 3, y is 5. At x equal to -2. -2, you know, from this point, this is -2. So we are looking for the x values. We have the x values of the a. We are looking for the y coordinate of this. Even if so we are going to substitute now -2 in the equation. So when we substitute this one, what do we get? -2 plus y equal to 8. It means that y equal to 10, right? So it means the coordinate of a equal to -2, which is the x, and the y, which is 10, right? So we have gotten the coordinates of b and the coordinates of a as simple as that. Find the area of the shaded region. We want to calculate the area of the shaded region, this shaded region. First, make this, remember this is a trapezium. So we have a trapezium and the curve. So make it appear as a trapezium like that. You can see this is a trapezium. So we can get the area of the curve, very simple. So let us check how we go about it. So how do you get the area of? There is two ways, but I want to show the most common. So area of the shaded parts or region equal to area of a trapezium minus area of the curve. Area of the curve. Yeah, for us to get the area of the shaded region, we get the area of the trapezium and then subtract the area of the curve. So first, let us calculate the area of the curve. How do we calculate the area of the curve? Area of the curve, area equal, we use integration method to get the area. And we have our limit as -2. We know our limit is -2, 3, x values, -2 and 3, because we know our x is -2 and 3. Now we are integrating what? We are integrating the curve, the function of the curve, that is x squared minus 2x plus 2 dx. That's what we are integrating. So we know how to integrate. This one is going to be x cubed over 2. This one is going to be minus 2 x squared over 2 plus 2x, and we are going to integrate this in the limits 3 to -2, right? So after doing all that, we are going to get, so you substitute the values here and you will find out that you will have 6 into or 6 minus 4. So make sure you get that. The first one, when you are using 3, you will get a 6. When you are using the limit -2, you are supposed to get -4, and then when you add, you get 10 square units. So the area of the curve is 10 square units. Now we go to calculate the area of a trapezium. Area of the trapezium. Area of a trapezium. We know a trapezium looks like this. That's what we know. This is the trapezium. These are two lines are parallel. This is the perpendicular height, right? So the perpendicular height has how many units? From here is -2 to 3. That is 5 units. So here we have 5. From here up to here, remember, from here up to here, we have y is equal 10. So this is 10. From here up to here, you'll check here. It is 5. Right? You know, how do you calculate the area of a trapezium? Is equal to a half into a plus b. times height. So that is it. So I have into 10 plus 5 times 5. This one will give us 15. 15 times 5, 75 divided by 2. So that one is 75 divided by 2. That one will give us 32.5. So the area of the trapezium is 32.5. But remember, how do you get the shaded region? The shaded region is area over trapezium subtract area of the curve. Area of the curve is 10 units. Area of the trapezium is 32. Therefore, area of the shaded region is 32.5 subtract 10. And that one is 20.5 square units. That's how you are going to make your 10 marks in paper 1.